Hello everyone, in this video I'm going to discuss condition for sustained interference and Fresnel biprism. Okay, now let us see conditions for sustained interference. Here the first condition is the two light waves superposing at a point must have the same wavelength or same frequency. That is, let us suppose if we consider two sources, it is S1 and it is S2, and these both sources are emitting waves. That is, here I am going to consider wave of first source and it is wave of second source. These two sources must have their wavelength same. It is the first condition. That is, both sources must have its wavelength same for sustained interference. And the second point is the amplitude of superposing light waves should be equal. That is, when we consider two sources, that is, let us suppose S1, second one is S2, and these sources are emitting light waves and it's both here the amplitude of both the waves must be equal or almost equal. And let us see third point, that is the two light waves, the two light wave superposing at a point should either have the same phase or have constant phase difference or have constant phase difference. That is, here from source S1 and S2, two waves are going to emit, and this is from second wave. Here crest and crest, tuft and tuft, and crest and crest. They all meet each other. That is, the phase difference between two waves are same. And one more thing, here from first source I'm going to consider another wave. Here also the phase difference is same. And one more example. This is first wave and this is second wave from source S2, and the phase difference between these two waves are constant. This is the third point, that is, the two waves have same phase or they have constant phase difference for sustained interference. Let us see the fourth point, that is, the sources emitting light waves should be very close to each other. This is fourth point. That is, let us suppose if we consider two sources S1 and S2, from these two sources light waves are going to emit, and the distance between two sources must be very small. This distance must be small for sustained interference. Okay, now let us see the fifth point. Fifth point is the distance of the screen from the two sources must be large. That is, here we have a source. From in front of this source we have placed two slits. From this source a light is going to emit, and this light waves are going to divide in slit, and then they are going to incident on screen. These are slits. These are slits. And the distance between source and screen must be large. This is the fifth condition. Okay, now let us discuss Fresnel biprism. Here, Fresnel used biprism to show interference phenomena. To show interference phenomenon, Fresnel used a biprism, and this biprism consists of two prisms of very small refracting angles joined base to base. That is, here I am going to take first prism, and this is the base and this is the refracting surface. And here biprism consists of two prisms. It is first one, and the second prism is attached base to base. This is the biprism. But in practice a thin glass plate is taken. But in practice they have taken a glass plate, and one of its surface is ground, that is, here they have grounded this surface and they have polished the next surface till a prism is formed, that is, such shape. A prism is formed with an obtuse angle, that is, obtuse angle here of 179 degree and two side angles of other side, that is, here a 30-minute and this angle is 30-minute. And also a biprism creates two virtual sources. Here let us suppose I am going to take a biprism, and here I am going to consider, here I am going to take a source and I will denote it as a S. From this source a light is going to incident on biprism, and after incidenting on refracting surface, this light wave is going to refract. Here also same, a light wave is going to refract, and similarly a next wave incident and it gets refracted. Here also same, a light wave incident and this wave gets refracted. And when we extend a line here, at both surface we get 2 points. It is S1 and this is S2. From this side it seems that the light is coming from these 2 points, and we denote these two virtual sources by S1 and S2. And here the sources produced are coherent because these two sources are produced by a single source, and they are coherent means they are having same wavelength. And this is all about Fresnel biprism.